Hello, I'm James Helfrich. I like to explain the composition and organization of the software design textbook. First, we'll start with the composition of the textbook. There are 5 sections: algorithm design, referring to everything that goes on within a function; modularization design, which describes how to create and organize functions; encapsulation design, which talks about how to design individual classes in isolation of the rest; class relation design, which refers to how to build classes that are interrelated; and finally, component and system design. Each section has 4 categories. The first category is tools, and that is how to represent design ideas. So at the algorithm level, this includes flowcharts and pseudocode. At the modularization level, this refers to structure charts and data flow diagrams. At the encapsulation diagram, we talk about class diagrams only as it relates to individual classes. In the class relation section, we talk about class diagrams too, and that refers to composition, inheritance, association, and all the different ways the class can relate to each other. And finally, in the component and system level, we talk about component diagrams and how to represent a system design using a design description. And this includes multiple views, each of which could be the things we discussed earlier, as well as other ones like entity relationship diagrams and things like that. Metrics refer to how to judge the quality of a given design. At the algorithm level, this includes algorithmic efficiency, as well as the dual maintainability metrics of understandability and malleability. At the modularization level, we refer to cohesion and coupling, both the classical sense and the new revised definition of each. At the encapsulation level, we refer to convenience, which is how easy it is for a client to use a class; fidelity, and this is the quality of the attributes in representing the design concern; abstraction, and how much we can shield the client from having to know implementation details about the class; and robustness, how much assurance we give the client that the class will work as expected. At the class relation level, we refer to adaptability, how easy it is to add functionality to the class without modifying the inheritance hierarchy; alignment, how does the inheritance hierarchy map to the design concerns; and redundancy, in other words, how little redundancy there is in the system in terms of duplicate code or functionality. We actually have no metrics for the component or system level. At the quality level, this refers to how to add asserts to catch bugs and how to create a program trace to determine the output of a given algorithm. At the modularization level, this is how to generate test cases and how to create drivers, both manual drivers as well as automation. At the encapsulation level, we talk about unit tests, and this is how to create a single unit test. And once again, this is for classes that are in isolation from the rest of the program, and test-driven development. At the class relation diagram, we go to unit test 2, and this refers to things such as mocks and doubles and spies and things like that, as well as how to use the debugger effectively. At the component and system level, we talk about the V model and how to design test cases and test plans at all levels of the design process. The final category is strategies, and this is best practices and techniques you can use to design better at each level. At the algorithm level, we talk about a collection of the strategies used to design if statements and switch statements more effectively, including simplifying Boolean expressions, how to use collections effectively, and how to define loops effectively. And this includes counter control loops, event control loops, collection control loops, as well as sentinel control loops. At the modularization level, we talk about recursion, top-down design, bottom-up development, and bottom-up testing, as well as functional programming. At the encapsulation, we talk about noun identification, like things like CRC cards, metaphors, and data protection. At the class relation level, we talk about polymorphism, the difference between ISA and HASA, how to manage large inheritance trees, and the collection of design patterns around object creation, such as factory, abstract factory, builder, and things like that. At the component and system level, we talk about algorithmic abstraction and the design patterns associated with that, message passing, and these are once again design patterns, separation of concerns, and this includes model view controller, command passing, interfaces such like facade, tokens and entities, and finally layered system design. In the table of contents, each chapter has the category for which it belongs. For an example, flowchart is a type of tool, functional programming is a type of strategy, and unit tests are a quality strategy. I've been teaching with this textbook for several years now. On average, it takes my students 40.79 minutes to complete the reading and the reading quiz for each chapter. The reading quiz is drawn from the exercises. They're given 5 chances, and each student is expected to get 100% on the reading quiz before they take class. The fastest chapter is the interface chapter, which includes things like facade and proxy, and that takes 27 minutes. And the slowest is the coupling chapter in modularization, which takes the students on average is 62 minutes. However, 45 minutes is the mode. In addition, there are a collection of appendices, including the glossary, further reading, best practices, and an index. Now, each individual chapter has 5 parts. The first part is the content, and this, of course, is the bulk of the chapter. It includes ample illustrations, tables, and callouts to make the reading experience easier and more enjoyable. Then we have a collection of examples, and these walk through problems sort of like the exercises and problems and challenges that the students might be asked to do. Then there's a collection of exercises. These are simple exercises focusing on testing the students' learning facts and comprehension things. These are great for reading quizzes. And finally, there are problems. Most problems are straightforward, but some involve thinking skills. These are good for in-class exercises or for homework. So for an example, in the data flow diagram chapter, this would be a very typical content page. We have a call out, and the call out says a data flow diagram represents the movement of data between program entities. I have an illustration, and here we have a data flow diagram, obviously. And then we have a table which pulls out the various properties of a data flow diagram. In addition, we have examples. And once again, each of these examples looks a lot like the problems. And we have the problem presentation, the solution, and a short discussion about why the solution works. We have a collection of exercises. These exercises are designed to be easily turned into reading quizzes. The slide deck has solutions for each one of these. We have problems, and these problems are designed to take anywhere from 5 minutes to 20 minutes for a student to do. These are really great things to do as an in-class activity. And once again, the slides have solutions and explanations for each, or you can also give them for simple homework assignments. And then we have challenges, and the challenges are more in depth. Some of these will take 3 or 4 hours. Some of them might take as many as 10 hours. These are good for a weekly lab or maybe a bi-weekly lab. Please select the subscribe button on the right. Every week we add new videos walking through examples or explaining some of the more difficult to understand concepts, which can supplement your class. Also, there's a collection of other videos which describe other parts of the offering, including the YouTube videos associated with this textbook, the slide deck associated with the textbook, or the overall philosophy of how this can be integrated into your class.